So now that we've seen the rationale and the proof for why the sum of the measures of the angles in a triangle is 180 degrees, again, all related back to the Euclidean postulate, we can start going through ways of classifying triangles according to their sides and angles, as well as seeing two remaining definitions and one remaining theorem about the angles in a triangle. We said before, when we were starting to look at the Euclidean postulate and its relationship to the angles in a triangle, that the two things most of us already know, or that people remember about triangles, is that all triangles have three sides and three angles. That's part of the definition. And that the sum of the measures of the angles in a triangle add up to 180 degrees. Well, that gives us a way of classifying triangles according to the types of angles that it has. Now, it's entirely possible, depending on the set of angles, that a triangle has only acute angles, that a triangle contains a right angle, or that a triangle contains an obtuse angle. And in this case, we classify triangles according to those types of angles. A triangle that has only acute angles is called an acute triangle. A triangle that has a right angle is called a right triangle. And a triangle that has an obtuse angle is called an obtuse triangle. Related to all of these, it's also possible that all of the angles in a triangle are the same size, the same way that all of the angles in a square are 90 degrees. Any polygon or triangle in which all of the interior angles are congruent is called an equiangular triangle. So, or in the case of a square, a pentagon, a hexagon, etc., an equiangular polygon. Go ahead, pause the video, copy down the classifications of triangles according to their angles, as well as the definition of equiangular. Come back when you are ready to move on. So those are classifying triangles strictly according to their angles. We can also classify triangles in completely separate ways according to their sides. In this case, we can either have triangles with three entirely different side lengths, like the one on the right, a triangle where two sides are the same length, like the one in the middle, or a triangle where all three sides are the same, like the one in the left. And in this case, we classify them as either equilateral, meaning equal-sided, isosceles, with two equal sides, or scalene, where every side length is slightly different. So go ahead, pause the video, copy down these classifications for triangles, as well as the diagrams that go along with them, keeping an eye on the spelling of isosceles specifically. Come back when you are ready to move on. So most commonly we call triangles with three equal sides equilateral, but really the term equilateral, meaning equal-sided, can apply to any polygon that has equal sides. A square, again, for example, all the sides of a square are equal, and so a square, by definition, is also equilateral, even though we see it most often with triangles. Isosceles and scalene stay in the realm of triangles and really don't go very many places other than that. We'll see isosceles with trapezoids when we get to that in the quadrilaterals module, but apart from that, they tend to stay within the group of triangles. So those are the classifications. Keep in mind that every triangle can be classified according to its angles and according to its sides. And other than an equilateral triangle, just knowing that it's isosceles or scalene doesn't tell us anything necessarily about the sizes of the angles, and so we have to be careful that we don't mix them up. Just because it has two equal sides does not mean the triangle is necessarily acute, right, or obtuse. So we also said that there were two remaining definitions as it relates to triangles specifically, but one that also refers to other parts of polygons. And that's the idea of an exterior angle. We said that the sum of the interior angles of a triangle were 180 degrees, and that's because those angles all occurred on the inside of the triangle. But it's entirely possible for us to extend one of the sides of the triangle and create what we call an exterior angle. And an exterior angle of any polygon is made by extending one of its sides. And by extending one of its sides, we mean taking the line segment that creates that side and extending it in either direction. So go ahead, pause the video, copy down the definition of exterior angle here, come back when you're ready to move on. So we can see that the exterior angle that is given as an example down here in red is made by an extension of what to us is the bottom side of that polygon, and the angle is made between the extension of that side and the next adjacent side over. So it's not this 180 degree angle down here, it is the angle right there. We could also create exterior angles off of the other two sides by just extending those sides and then finding the angles between the extended sides and the adjacent side. Well, once we have an exterior angle, we can talk about the angles of the triangle that were not a part of creating that exterior angle. So, for example, the angle that is being colored in red now makes a linear pair with that exterior angle, we have two other angles that don't make linear pairs with that exterior angle in a triangle. And we call those, specifically in triangles, remote interior angles. And again, this refers only to the angles in a triangle. Specifically, the two angles that do not form linear pairs with a particular exterior angle are called that angle's remote interior angles. Go ahead, pause the video, copy this down, and come back for one last slide. Now, one of the properties of remote interior angles is that they are very closely related to the exterior angle that they refer to. And we're going to show you the theorem here without a proof because you're going to prove it as a part of your practice after this. And it turns out that the exterior angles theorem of a triangle tells us that the measure of an exterior angle in a triangle is the sum of the measures of its remote interior angles. Now, this has to do with the fact that both the interior angles and the exterior angle are related in some way to that angle that does not qualify as a remote interior angle in the triangle. So go ahead, pause the video, copy down the exterior angles theorem, and then once you have done that, you are ready to move on to the practice and be done with the video.